This question is asking us to find the radius of convergence for this power series. So this power series is a geometric one and it converges when x is less than 1/4. So that means that the radius of convergence is 1/4. Anything outside of this 1/4 and the power series doesn't converge. Here it's asking us to find the radius of convergence for this power series. So you would do the limit as n approaches infinity of a sub n plus 1 over a sub n. So this is a sub n plus 1, and divided by a sub n means times 1 over a sub n. So you just get the reciprocal of this one. You cancel out these terms and you're left with 2n plus 2 times 2n plus 1 times x squared over n plus 1. You can move the x squared outside since you're only finding the limit of n. So the limit as n approaches infinity of this expression, you can distribute these values to get this, use L'Hopital's rule, and get the derivative to find that the limit as n approaches infinity is infinity, which means that for all x's that this function has, it's diverging. This question is asking us to find the interval of convergence for this power series. So you would do the limit as n approaches infinity of a sub n plus 1 over a sub n. When you get it, when you finish doing this, you get x times the limit of n over n plus 1, which is equal to x. So the absolute value of x has to be less than 1 for it to converge, meaning that the interval of convergence is from -1 to 1.